Alrighty, so we are going to be reviewing for our Unit 7 exam, which will have a lot of factoring on it, since that is what we learned in Unit 7. But it could still have stuff from the past, because we like to always review stuff from the past. So this first question says, express in simplest form. Alright, let me look at my first parentheses. There's no number in front of it. I mean, technically there's a 1, but if you multiplied by 1, that's not going to change anything. So I'm just going to rewrite it without the parentheses. Then the second parentheses, there's a negative 1 in front of it. So I have to distribute this negative 1. So negative 1 times negative 2x is positive 2x squared. Negative 1 times positive 4x is negative 4x. And negative 1 times positive 2 is negative 2. And now we could start combining like terms. 3x squared plus 2x squared is 5. Do not change the x squared. Then 4x minus 4x actually becomes 0 because 4 minus 4 is 0. And then negative 8 minus 2, or negative 8 plus negative 2, gives us negative 10. And this would be our final answer. That is written in standard form since the biggest exponent comes first, so we are good. All right, let's look at question 2. If A equals this and B equals this, then what is A minus B? Okay, so first they want me to write down A. This is A. 3x squared plus 5x minus 6. That's a whole group, so I'm going to put it in parentheses. Then they want me to minus B, which is negative 2x squared minus 6x plus 7. All right, so this is very similar to the problem before. The first parenthesis, there's nothing we have to worry about. Now with the second parenthesis, negative times negative 2x squared is positive 2x squared. Negative times negative 6x is positive 6x. And negative times 7 is negative 7. All right, let's combine like terms. 3x squared plus 2x squared is 5x squared. So right away I could get rid of C, and I could get rid of D. Then 5x plus 6x is 11x. And negative 6 minus 7 is negative 13. Our answer is choice B. All right, let's look at number 3. Given this function, find the value of h of 1/2. What that means is that A, which used to be in the parentheses, you see A used to be in the parentheses, but now we have a 1/2 in the parentheses. This means that A equals 1/2. So if we're trying to find h of 1/2, that means we have to take this expression, and anywhere we see A, we are going to replace it with 1/2. And we could do that right in our calculator. Like you could literally tell your calculator that A equals 1/2, and you can do the rest. 1/2 squared minus 3 parentheses. I made a little mistake. One second, I typed something wrong here. Okay, I meant to put parentheses 1/2 minus 5. And that gives me negative 6. So h of 1/2 equals negative 6. Let me just make sure I typed that in correctly. 2, A is 1/2 squared minus 3, 1/2 minus 5. Yes. All right, 4 is very similar. We are told that originally we have g of x. Now we have g of negative 2. That means that x got replaced with negative 2, so they are equal. So if we're trying to find g of negative 2, that means with this expression, anywhere I see x, I'm going to replace it with negative 2. All right, let's do it. 2 parentheses negative 2 to the third minus 3 parentheses negative 2 plus 5. And that gets us negative 5, which is choice D. All right, let's look at this next question. use the distributive property and write our answer in standard form. Okay. So x times x squared. That would give us x to the third. Then x times x. That would give us x squared because we add the exponents 1 plus 1. And x times 3 is 3x. Okay. Then negative 3 times x squared is negative 3x squared. Negative 3 times x is negative 3x. And negative 3 times 3 is negative 9. All right, let's combine like terms. This is the only cubed term I have. Then I have an x squared minus 3x squared, which would give me negative 2x squared. And then 3x minus 3x would actually cancel off. And then I'd just be left with my minus 9. This is in standard form because the exponents are decreasing from left to right. Alrighty. Let's look at number 6. Again, we're going to distribute. X times 4x is 4x to the third power because x times 4x squared. Then x times negative 4x is negative 4x squared. X times 9 is positive 9x. Then we have to multiply this 1. 1 times 4x squared is just 4x squared. 1 times negative 4x is negative 4x. And 1 times 9 is 9. Now let's combine like terms. This is the only cubed term I have, 4x to the third. Then negative 4x squared plus 4x squared actually becomes 0. Then 9x minus 4x is 5x. And I bring down this positive 9. This is in standard form because we're going from the highest exponent to the exponent with the 1 to then the constant. Alrighty. Now, for these following questions, we are going to be expressing the trinomials as the product of two binomials. Basically, we're going to be factoring these. First, I want to put it in standard form. So it would go negative x squared, then the positive 12x, then the 28. Okay. I don't like having any negative in front of my x squared, so I'm going to divide out this negative. I don't like that. So that'll leave me with x squared minus 12x minus 28. Okay. Now, we are going to be finding what adds to negative 12 and what multiplies to negative 28. And these are going to be our two binomials. We're finding what adds to negative 12, two numbers that add to negative 12, but we need those same two numbers to also multiply to 28. So start by thinking, what can multiply to 28? 1 and 28, 2 and 14, say 28 divided by 4, 4 and 7. 2 and 14 seems like it would work. Let's see which one should be negative. 2 minus 14, or do we do 14 minus 2? Because I want negative 12, it's a positive 2 and a negative 14. And this is our final answer. All right, let's look at the next one, very similar. Let's first write it in standard form. Negative p squared minus 3p plus 18. We never want a negative in front of our p squared. So we are going to divide each of these terms by the negative. That will leave us with negative p squared. Negative 3p divided by negative is positive 3p. And 18 divided by negative is negative 18. Perfect. Now we are going to be finding what adds to 3 and what multiplies to negative 18. What adds to 3, but also multiplies to negative 18. All right, so 18. Factors of 18 are 1 and 18, 2 and 9, and 3 and 6. If I'm trying to find what could add to 3 and 6 seems good, but I might need to do some subtracting. 3 minus 6, well, that gets me negative 3. What about 6 minus 3? Oh, that gets me 3. So 6 and a negative 3. 6 and a negative 3. So I would have p plus 6 and p minus 3. Perfect. Alrighty. Let's look at this next one. It's already in standard form and there's no negative in front of the squared term. So we could just do the add multiply right away. So I know I'm going to be separating my y squared into y and y. And I'm going to be asking myself, what two numbers add to 4? But I also need those same two numbers to multiply to negative 32. All right, 32. We could think of 1 and 32. 2 and 16. 32 divided by 3, does that work? No. 32 divided by 4. 4 and 8. 32 divided by 6. No, so that's it. And 4 and 8 definitely works, but we would need to have a minus 4 in order to end up with a positive 4. So minus 4 and a positive 8. And double check, negative 4 plus 8 does equal 4, and negative 4 times 8 does equal negative 32. So this is our final answer. Alrighty. Let's do some more practice with this. 10 is already in standard form. There's no negative we need to take out. There's nothing that's common, so we just go straight for adding to 8 and multiplying to 15. To separate the y squared, we've got y and y. And now, what numbers multiply to 15? 1 and 15, or 3 and 5? And luckily, 3 plus 5 does get us 8. That one was nice and simple. Make sure you're pausing this video and actually trying these to see if you could do them on your own. Let's look at number 11. Let's put this in standard form. X squared plus 23x plus 42. Good. There's nothing we could divide out, so we're going to be finding what adds to 23. Remember, this side step is not necessary, and what multiplies to 42. X squared becomes x and x. All right, let's think about it. What numbers multiply to 42? 1 and 42, 2 and 21. Oh, right there, 2 and 21 would equal 23. And they could both be positive. Perfect. Good. All right, let's look at number 12. Number 12 says, express the given trinomial as the square of a binomial. You will see what that means in a second after we find this answer. Let's look at this. There's nothing to divide out since we only have a 1 in front of this, and all three terms do not have an a. So we're just going to be finding what adds to negative 8 and what multiplies to 16. A and A. So what adds to negative 8 and multiplies to 16? Well, multiplying to 16 could be 1 and 16, 2 and 8, or 4 and 4. Hey, that works. But the only way I'm going to get a negative 8 is by having a negative 4 and a negative 4. As you should be able to see, both of these are the same exact parentheses. So you could end up just writing it as a minus 4, and since there's two of them, squared. And this means the same thing as this. Perfect. Let's look at number 13. What are the factors of this? First we see, is there a number we can divide out? The smallest number is 4, but 25 and divided by 4 does not give us a whole number. We can't divide by 3 or 2, so none of them work. So this is when we do the square root method. The square root of 4x squared is 2x. And the square root of 25 is 5. I know the only way I would get a negative 25 is if I had a negative 5 and a positive 5, which is answer choice B. Let's look at 14. Again, there is nothing we can divide out here, so instead we are going to take the square root. The square root of 9x squared is 3x, and the square root of 16 is 4. And we need to have a negative 4 and a positive 4, which is answer choice D. Good. Alrighty. Now 15 is a little throwback to last unit, which we love. We love to have little reviews. So let's see what it says. A high school sponsored a badminton tournament. After each round, 1/2 of the players were eliminated. Well, if I'm eliminating, I'm definitely going to be minus. So let me get rid of anything here that says plus. Okay? And 1/2 is 0.5. And it says they started with 64 players after 3 rounds. I know that time or rounds or whatever has to do with an amount of time becomes the exponent. And I put the factor that it's changing by inside the parentheses, which is answer choice A. Let's look at 16. In the equation, A equals P, which is your starting value. 1 plus or minus R. R is your percent. And then T is the time. A is the total amount, which they just told us. P is the principal amount. That means starting. R is the interest rate, which is the percent. And T is the time. Which of the following statements correctly relates information regarding the annual interest rate for each given statement? A says, for A equals P, parentheses 0.86T, the principal amount of money is decreasing at 14% interest rate. That could possibly be true. If the number inside parentheses is smaller than 1, decreasing makes sense. Okay, B. For A equals P, parentheses 0.68, the principal amount of money is decreasing at 68%. Okay, yeah, because it's under 1. These are both over 1, which is why they're increasing. Okay, all of them make sense so far. Now, let's look at A. The amount of money is decreasing at 14%. That means I would do 1 minus 14% becomes 0.14. And 1 minus 0.14 is 0.86. So my answer actually is choice A. Let's look at B. B was saying that the principal amount is decreasing at 68%. That means you would do 1 minus 0.68, which would not get you 0.68. And the same for C and D. All right. Now let's look at questions 17 through 20. For questions 17 through 20, we are going to be factoring the given polynomials completely. This is where we might first have to find a GCF. And then if we're left with a binomial when we have 2 terms, that's when we might have to do the perfect square method. But if we were left with a trinomial, 3 terms, we would find what adds to the B term, the middle term, and what multiplies to C, the last term. All right, question 17. 3x squared minus 75. The smallest number there, 3z squared minus 75. The smallest number there is 3, and 75 does divide by 3. So let's take out this 3. That will leave us with 3, parentheses, z squared minus 25. Okay, we can't do the adding and multiplying method because we don't have a trinomial, but z squared is a perfect square and 25 is a perfect square. So let's separate this. Always write the GCF on the outside. Z squared separates into z and z, and the square root of 25 is 5 and 5. The only way to get a negative 25 is with a minus and a plus. Perfect. And that is our final answer. There's nothing more to factor. Let's look at 18. 4n to the third minus 49n. Let me first see. Can I do 49 divided by 4? No, that doesn't work. And it wouldn't divide by 2. So there's no number I could take out of here besides 1, but that wouldn't help us. But they both do have an n, so I could factor out an n. That'll leave me with 4. If I have 3 n's and I take away 1 n, I'll have 2 n's. Minus 49 with no n's. Good. Now I realize that both of these are perfect squares. The square root of 4 is 2. To separate n squared, it would be n and n. And the square root of 49 is 7. I would have a minus and a plus. Perfect. And that is all we can do there. There's no numbers that we could take out. All right, let's look at number 19. All right away in front of my x squared, I see there's a 3. And all 3 of those terms do divide by 3. So I'm going to divide all three numbers by 3. They don't all have an x, so I can't divide out an x. All right, so my GCF is just 3. 3 divided by 3 is 1. I don't need to write that. Just leave the x squared. Negative 36 divided by 3. Negative 36 divided by 3 is negative 12. Bring down the x. And 60 divided by 3 is 20. Perfect. Now, because I have 3 terms, I'm going to try to find what adds to negative 12 and what multiplies to 20. What adds to negative 12 and what multiplies to 20? Well, numbers that multiply to 20 are 1 and 20, 2 and 10, 4 and 5. The only one that with adding would ever equal 12 is 2 and 10. But because I want to equal a negative 12, I need to make both numbers negative. Perfect. All right, let's look at 20. 5 is my smallest number, and 5 does divide by all of these. But there's not a z in each of them, so I can't take out a z. 5 divided by 5 is 1. Just leave it as z squared. 20 divided by 5 is 4. Bring down the z. And negative 105 divided by 5 is negative 21. Perfect. So now I'm going to be asking myself, what adds to 4 and multiplies to negative 21? What adds to 4 and multiplies to negative 21? 21 could be 1 and 21 or 3 and 7. Hey, 3 and 7 would end up equaling 4, but I need a positive 4. So that means that I have a positive 7 minus 3. Good. You just want to make sure that first you're factoring out a GCF. If there's ever a number in front of the x squared term, that number probably divides. And then if you're left with 2 terms, you do the square root method. If you're left with 3 terms, you see what adds to the middle and multiplies to the end. Good. All right, let's look at number 21. The volume of a rectangular solid is represented by this polynomial expression. Express the dimensions of the solid as a completely factored expression in terms of z. So we're just factoring here. Just a lot of words to tell us to factor. All right. We could divide by 2, so that's great. And they both have an x, so I could take out an x. So I would have 2x parentheses. 2 divided by 2 is 1. X to the third divided by x leaves me with x squared minus 98 divided by 2 is 49, and the x's would cancel out. And now, if I'm trying to factor x squared minus 49, I'd be left with 2 sets of parentheses, x and x. The square root of 49 is 7 and 7, and the only way to get a negative 49 is with a negative and a plus. All right. This is the same kind of question in the next one. The volume of a rectangular solid is represented by this polynomial. Express it in factored form. All right, so we have x to the third minus 9x. I'm going to factor out an x from each one because there's no number I could take out. So I would have x squared minus 9. Now I will separate that into 2 parentheses. I'll be left with x and x. The square root of 9 is 3. 3 and 3. That will give me a minus and a plus. Alrighty. Let's look at the next question. Alright, this is a multiple choice question. All right. The Jamison family kept a long log of the distance they traveled during a trip as represented by the graph below. During which interval was their average speed the greatest? All right, this is kind of like doing slope, where you're doing the second hour minus the fourth hour, means it changed by 2 hours, and how much did the distance change? From the fourth hour to second hour, we went from 180 to 110. That's 70. And 70 divided by 2 is 35. Let's see the next one. From the 6th hour to the 8th hour, you changed by 2 hours. At the 8th hour, we were 350. At the 6th hour, we were 230. That means the speed went up by 120 divided by 2 is 60 miles per hour. Then C, the first hour to the second hour was 1 hour change. And then the second hour you were 110, but the first hour you were 40. So we went up by 70. So the slope there is 70. And D, the 8th hour to the 10th hour is 2 hours. The 10th hour we were 390. And the 8th hour we were 350. That's 40. 40 divided by 2 is 20. So we were the greatest in answer C. If you look at the graph, that's when the graph was the steepest. Nice. All right. Let's look at 24. The table below shows the average diameter of a pupil in a person's eye as he or she grows older. What is the average rate of change from age 20 to age 80? Remember, these are our x's, so this is x1 and x2. These are our y's, y1 and y2. And we use the formula y2 minus y1 over x2 minus x1. Okay? So y2, y2 is 2.3 minus y1 is 4.7. Then x2 is 80 minus x1 is 20. And let's type this in the calculator. 2.3 minus 4.7 over 80 minus 20 leaves me with the answer of negative 0.04. Good. Alrighty, let's look at question 25. Mrs. Fox asked her class, is the sum means to add, is the sum of this and this rational or irrational? So let's do 4.2 plus square root of 2, and let's see what answer we get. 4.2 plus square root of 2. I get 5.6142 ... which is irrational because the decimal does not end or repeat. And the rest of the question says that Patrick thought it was irrational. So we want to know, is he correct or incorrect? We could say, so he is correct. Good. Because he did think irrational, and that's what we found, so he is correct. All right, the next one. Determine if the product means to multiply. Determine if the product of these are rational or irrational. Well, let's actually do it. 3 square root of 2 times 8 square root of 18. That gets me 144, which is rational because it is a whole number. Perfect. All right, now let's get some review solving inequalities. So remember, we always like to bring our variable to the left side. So I'm going to add this to y, add to y. I would end up getting 1.8 negative 0.4 plus 2 is 1.6y, which is greater than or equal to 2.2. Now I want to bring my constant to the right side, so I'm going to subtract 1.8. I would get 1.6y is greater than or equal to 2.2 minus 1.8 is 0.4. Divide by 1.6. I get 0.25. I do not need to flip my sign because I did not divide or multiply by a negative number. Let's look at 28. I'm going to bring my x over by minusing 1.04x. So I would get 3,600. 1.02 minus 1.04 gets me negative 0.02x is less than 2,000. Now I'm going to subtract 3,600. I'll get negative 0.02x is less than negative 1600. Divide by negative 0.02. Because I'm dividing by a negative number, I will definitely have to flip my inequality symbol. And let's see what I get when I do this. I get 80,000. Perfect. Alrighty. Let's look at 29. On the set of axes below, graph the following systems. Ooh, I gotta practice this. Alright, let's write the first one down. 2x plus y is greater than or equal to 8. Alright, I need to bring this 2x to the other side. So I'm going to minus 2x minus 2x. That would give me y is greater than or equal to negative 2x plus 8. 8 is by itself. That means I start by going up 8. 1, 2, 3, 4, 5, 6, 7, 8. Then I go down 2 to the right 1. Down 2 to the right 1. And keep following this all the way through. So we could have a very, very neat graph. You could also go up 2 to the left 1. Because this is equal to, we get a solid line. Put some arrows. And it's a greater than symbol, so we shade above. And this was the graph of 2x plus y is greater than or equal to 8. All right, let's look at the next one. Y minus 5 is less than 3x. All I got to do is add this 5 to bring it to the other side. And I get y is less than 3x plus 5. I'm going to start by going up to 5. 1, 2, 3, 4, 5. And now I go up 3. 1, 2, 3 to the right 1. Or I could go down 3. 1, 2, 3 to the left 1. Down 3. 1, 2, 3 to the left 1. 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 This is just a less than symbol, so I use a dotted line. And then, because it is a less than symbol, I shade below. So this area would be my solution set. And the question says, determine if 1, 8. So 1, 1, 2, 3, 4, 5, 6, 7, 8. This point right here, determine if it is in the solution set. The answer would be no, because 1, 8 falls on the dotted line. If it was a solid line, that's okay, but it needs to be on a solid line or inside the double shaded area. Alrighty. Now let's look at question 30. This is another one. We're going to graph this again. So let's look at the first one. Negative x plus 2y minus 4 is less than 0. I'm going to add x to bring it to the other side, and I'm going to also add 4 to bring it to the other side. So I get 2y is less than x plus 4. I'm then going to divide by the 2 to get the y by itself. That will give me y is less than 1/2 x plus 2. I'll start by going up 2. And then my slope is 1/2, so I go up 1 to the right 2. Up 1 to the right 2. Up 1 to the right 2. Then I could also go down 1 to the left 2. Down 1 to the left 2. Follow this pattern. And it will need to be a dotted line since it's just a less than symbol. This is the graph of negative x plus 2y minus 4 is less than 0. Because it's less than, I shade below. And the other one is 3x plus 4y plus 4 is greater than or equal to 0. Minus the 3x minus the 4 minus the 3x minus the 4. That'll leave me with 4y is greater than or equal to negative 3x minus 4. Then I divide all numbers by 4. I do not need to flip my sign. I'll have negative 3 over 4x minus 1. So I start at negative 1, and then I go down 3, 1, 2, 3, to the right 4, 1, 2, 3, 4. Down 3, 1, 2, 3, to the right 4, 1, 2, 3, 4. We won't have enough space. Now let's go up 3, 1, 2, 3, to the right 4, left 4, 1, 2, 3, 4. Up 3, 1, 2, 3 to the right 4. 1, 2, 3, 4. Left 4, I mean. We will use a solid line since this isn't equal to. Let me write the original problem. 3x plus 4y plus 4 is greater than or equal to 0. And then because it's greater than, we shade above. So this is our solution set. And the question says, determine if 0, 0 is a solution set. Oh, well, Stefan said that 0, 0 is. Determine if he is correct. This person is correct. Because 0, 0 falls in the double shaded area. Yes, perfect. Alrighty. Now we are going to look at a word problem. All right. When visiting friends in a state that has no sales tax, 2 friends went to a fast food restaurant for lunch. The Browns bought cheeseburgers, 4 cheeseburgers. They told me to use C for cheeseburgers. 4 cheeseburgers and 3 medium fries for $16.53. The Greens bought 5 cheeseburgers and 4 medium fries for $21.11. Good. That is how you write the equations. Nobody should get that wrong. Now it says, the Greens said that since their bill was $21.11, each cheeseburger must cost $2.49 and each medium fries must cost $2.87. Are they correct? Let's see. The first one. For the first person, if I have 4 cheeseburgers that cost $2.49 plus 3 fries that they're saying cost $2.87, does that equal $16.83? 53? It does not. So, not correct because it actually would equal $18.57. If you tried the other one and you put in those prices that they had, let's see what would happen. You would think it's, oh no, it's also not correct for that person either. It's also not correct because when you try this one, you get $23.93, which is not what you want to get. All right, so it's not correct. All right, so now let's find what is correct. So let's write these equations. 4c plus 3m equals 1653. And then 5c plus 4m equals 2111. If you remember, we can solve this by timesing the first equation by 5 and the second equation by 4. Since none of them are negative, we need to make it negative 4. So we will get 20c plus 15m equals 1653 times 5 is 8265. Okay, then negative 4 times 5c is negative 20c. Negative 4 times 4m is negative 16m. And negative 4 times 2111 is negative 8444. All right, let's add these together. These would cancel. That's why it's the elimination method. 15 minus 16 would leave me with negative 1m. And then 82.65 minus 84.44 is negative 1.79. I divide each of these by negative 1, and I would get that the price of the medium fries is $1.79. Now to find how much the cheeseburgers cost, I could plug into the first equation 4c plus 3. I just found that the medium fries are $1.79 equals $16.53. So let's solve this equation. 3 times 1.79 is 5.37 equals 16.53. I will subtract the 537. No, it's 1653 minus 5.37, and I get 11.16. Divide by 4, and I'll find out that the cheeseburgers are $2.79. Perfect. These are the two prices. And I just want to put this in order. I don't like how I got out of order. This was the second step, so we should put that first. We should put that second, I meant. So this was our first step, and this is our second step. Okay. Alrighty, and let's look at this very last problem, which is very similar to the problem we just did. Alyssa spent $35 to purchase 12 chickens. She bought two different types of chickens. American chickens cost that much? Okay. So the American chickens, well, she bought two chickens. The two different types of chickens she bought are American and Delaware chickens. She bought 12 of them. Okay. The American chickens cost $3.75, and the Delaware chickens cost $2.50, and her total price was $35. Perfect. All right. Now they want us to solve this. So, to solve this, again, we could use the same method that we just used. Times the first equation by the second number, 3.75, and times the second equation by 1, because none of them are negative, make it negative. So we would get 3.75a plus 3.75d equals 3.75 times 12 is 45. Okay, then when we multiply the negative, everything will just change signs. Good. Now let's add these equations together. This would cancel out. Then 3.75 minus 2.50 is 1.25d, and 45 minus 35 is 10. We do 10 divided by 1.25, and we find that the price for the Delaware chickens were $8. Now use the first equation, a plus d equals 12. I don't know what the a is, but d is 8 equals 12 minus 8 minus 8. We will find that the American chickens are four. Purchased 4 of them. So she purchased 8 Delaware chickens and 4 Delaware chickens. Okay, good. Now question C says, so that is all for question B. Now question C says, each American chicken lays 2 eggs per day. Okay. So we have 4 American chickens right now. Americans equals 4. And if they lay 2 eggs a day, that means the Americans lay 8 per day. 8 eggs per day. Okay. Delaware chickens lay 1 a day. Well, there's 8 Delaware chickens times 1 egg a day means they also lay 8 eggs a day. Okay. Alyssa only sells eggs by the full dozen for $2.50. Okay. So right now, how many eggs do they have? 8 eggs, and 8 eggs is they have 16 eggs, okay? She only sells her eggs by the full dozen. Determine how much money she expects to take in at the end of the first week with her 12 chickens. Okay, if they have 16 eggs a day times 7, that would be 16 times 7 would be 112 eggs in the week. So 112 eggs in the week. And she only sells it by the dozen, so we need to divide that by 12. So that would mean 9 dozens. And each dozen gets her $2.50. So 9 times 250 is $22.50. All right, let me go over this one more time. So the American chickens have 2 eggs a day. She had 4 American chickens. So 4 times 2 means they would lay 8 eggs a day. Then there's 8 Delaware chickens. They lay 1 egg a day. So 8 times 1 means they would lay 8 eggs a day. So in total, she would end up getting 16 eggs in a day. There's 7 days in a week. So 16 times 7 is 112. She would have 112 eggs in a week. Okay? But she only sells them per dozen. So I have to do 112 divided by 12 since there's 12 eggs in a dozen. That means she could make 9 dozen. Yes, there would be some leftover eggs, but she doesn't sell the leftover eggs. Then the 9 dozen times $2.50 means that she would end up making $22.50. And that wraps up our review. Remember, the last question of the exam is going to be on systems of equations. The second to last one is going to be on system of inequalities. And then we're going to have a lot of other questions on factoring and some other random review of things that we have learned in the past.